science is like around us, and it's a way to explore the world we are living in. So my name is Somasundaram, and I'm a third year PhD student at Indian Institute of Astrophysics, Bangalore. And alongside with me, I have two of my colleagues, Ms. Parvati and Ms. Seetha. Both are doing PhD at IIA, and we welcome you all to this interview for DOOT magazine. So DOOT magazine is an initiative led by the young researchers at IIA, and it's broadly aimed to enhance the outreach, the astronomy outreach program, and to popularize our science. And it compile and decipher the ongoing research works of the students, the faculty members, and in general the science, whatever the basic science we have. So it published biannually, and it since its inception in 2020, we almost like released 7 issues with over 120 articles. So among the so many sections we have in the DOOT article, our DOOT magazine, so we have one most compelling feature that is called the interview section, where we engage insightful conversation with some distinguished scientists with various fields, not concerning to astrophysics or astronomy things. And there our aim is to not only to uncover their scientific achievements, but to know their motivations and inspirations and the stories behind their success. So by sharing these narratives, we hope to inspire the young aspirants in this field and who are passionate about the science exploration. So we are excited to embark this intellectual journey with us, with our esteemed guest. So without further delay, so let's begin the interview. So over to you, please.
So hello everyone. So today for this interview we have with us Dr. Seetha Somasundaram. She is an Emeritus Scientist and an Honorary Member at Raman Research Institute, Bangalore. She is superannuated as an Outstanding Scientist from the UVIT Satellite Center in January 2019 after serving in ISRO for nearly 39 years. She was earlier the Director at the Space Science Program Office at ISRO headquarters and was therefore responsible to ensure the coordination of all space activities of ISRO. From the famous Mars orbiter mission Mangalyaan to AstroSat, Dr. Seetha Somasundaram contributed extensively to the development of space science instrumentation for Indian satellite missions. Dr. Seetha, as she is popularly known among her students and friends, is a recipient of various awards, including the CV Raman Young Scientist Award in Physics. She was even accorded the Best Woman Scientist Award for the year 2012 from the Astronautical Society of India. A pioneer in her field, Dr. Seetha Somasundaram has made the country proud one space mission at a time. So we are elated to have her present today for the DOOT interview. Her exceptional contributions to space science and instrumental role in Indian satellite mission make her a true pioneer. Welcome, Dr. Seetha. We look forward to have an insightful conversation with you. Thank you for joining with us today. So I think we can. Yeah. I think we can start with our first question.
Sure. Yeah. Hello, ma'am. So the majority of the readers of DOOT are students. So it will always great for students to know essential qualities and values from the lives of great individuals like you. That can shape their past and contribute to their personal and professional developments. Since you are here, could you share your student life experience and motivations that led you to pursue a career in astronomy and space science?
My student life has been in different places. My father was in a transferable job, so I have studied in Bangalore, Delhi, etc. My schooling I completed in Delhi, and my undergraduate also I completed in Delhi University. And then I did my MSc in Chennai, Madras, and then my PhD was in Bangalore. So studied in various places. Astronomy for me per se, I have been, as you notice, in very urban places. I have lived in urban areas. So my interest in student days was mainly in science subjects. So I took PCM, but not biology, not because I did not like it, but one essential part of biology was dissection, and I did not want to do it. So though I was very interested in biology, so I took PCM and then moved on to physics. Astronomy as such, I started only after I joined the Indian Space Research Organization. Till then, I have not been connected with astronomy. And those days there was no Google, there was no social media, etc. So primarily physics, and right from my school days I have been interested in experimental physics, both in my BSc and in my MSc project was also in experimental physics. So that has been my interest, and I was very happy that when I joined ISRO, starting from my interview for ISRO, I was being questioned for instrumentation, etc. And when I joined, I actually was initially involved in applied physics. there is a division called Technical Physics Division, which was there. That division was the one which was founded, or I should say, that was the starting ground for many people who are in the satellite center. So many of the people who are in the satellite center came from the physical research laboratory along with Professor Rao. He brought forth a team of members, and so they all joined technical physics. So I was not there at that time, but many of them then from there grew on to become directors, etc. at various divisions, which then grew into groups, which then grew into centers also. So I joined Technical Physics Division in 1980, and at that time we were still working on remote sensing satellites, that is the Bhaskara. I joined in 1980, and so my first project was on acoustic emission. So that is applied physics. We thought we would use our physics to actually find, do a non-destructive testing of structures to find whether they have cracks, etc. So acoustic emission was meant for this. This is something like your ultrasound scanning you do. Yeah, similar thing. There is also ultrasound only, using ultrasound. So I worked on initially on some detectors and preamplifier, and to see whether we can detect, etc. And then we decided, okay, this method works and we can characterize the signals which come out in terms of what cracks are there. And so we decided to propose for a full-fledged instrument which would have some 8 channels which we could mount on various places around the structure and see the signal, because that was a time when I got used to this idea of so-called triangulation, which you use in GPS, which we also had when we worked on the gamma ray burst experiment. So if you mount these sensors on various places, you could also find where exactly the crack is, and so on. So, and also find how the signals get transmitted through the material over the various sensors. But then when this machine was actually approved for, it was a few lakhs, so I went through the regular process of approvals. Then it was felt that it's better that rather than do it as an R&D, do it as an engineering project. So it actually went to another group called the structures group, which would actually build the structures, and so they would be more appropriate for this. So, and at that time, there was a rocket experiment being built by one of my colleagues called Shaila. She was working on that. She was developing a rocket experiment for observing X-ray sources. This was to be sent on one of the sounding rockets, which was launched on from Tumba. So suddenly she had to leave the job, and I took over from her at the final stages of that payload, and that's how I entered into astronomy. And at the same time, though, we were working on a project report for an X-ray, full-fledged X-ray astronomy experiment with TIFR for flight on a future Indian satellite. So I worked on that project report also, along with some of my senior colleagues, and we were also working at that time on proposals for upcoming satellites. I told you the background. The Bhaskara satellites were there. Bhaskara satellites were relatively large for that time, around 400 to 500 kg. So they had to be launched on Russian launchers. So we thought we would have to wait for Indian satellites to be launched on Indian launch vehicles, and so we were making these proposals and also working on, as I said, the rocket experiment. And in parallel with that, I started working on scintillator detectors. The rocket experiment was a gas-filled proportional counter. Scintillator, we used to work on a few experiments as such. So for example, suppose we had a large scintillator of the order of 5-inch diameter, and we thought we could again use multiple photomultiplier tubes to actually localize where the incident had a high energy X-ray or gamma rays. So that was a lab experiment I was working on. So several things like this used to go on in parallel. And then in 1982, I should say, I also started working on optical astronomy. That is where my connection with Indian Institute of Astrophysics starts early on. So while these proposals were there, till the satellite or the launch vehicle comes, what do we do in astronomy? So we decided we would use the optical telescopes to observe the optical counterparts of the X-ray binaries. So my first visit to Kavalur was in 1982, somewhere in February, and you can imagine, I don't know if you can imagine, because Kavalur is no longer that great a site now, but going in the very, very good period of January to March, which is the excellent period for Kavalur, and then I go there and this dark sky and multitude of stars there. For me, it was the first time I saw so many stars. So that's how my journey into astronomy started. So I should say it is a little serendipitous, but at some stage it was bound to come because we were in the space arena and space was to be used for astronomy.
So, in your career path as a woman, did you face any difficulties? Like that time, as you said, there is no Google, nothing, and what you faces there?
Okay, luckily for me, right from my school days, I have been asking that I should, though the societal, according to me, women per se are, I won't say equally capable, they are also capable in science. Why I don't want to say equally? Because I don't want to compare between people. Each one, according to me, has some special capabilities, whether they are a girl or a boy. And so I used to say that I will do what I like, and even that time and even now, I think the societal pressures are what restricts a woman or a girl to do whatever. And so slowly we have got over it. Now you see many working women, you see many working women in various areas which was not there at that time. But yeah, gradually we have got over it. So for me, for example, so to study, initially my parents weren't willing to allow me to stay in a hostel. But then I said, okay, BSc, you're not allowing me, MSc, I am staying in a hostel. And they said, okay, get into some IITs because those hostels are better maintained. That's how I got into IIT Madras and did my MSc there. There I stayed in a hostel. And after that, I definitely said, I am going to start working. That was one of the things I told them. And I also said that I have to be economically independent. That's not because I was very keen on growing very rich or anything, but primarily just to overcome some of these societal pressures. According to me, that is one of the factors which forces girls, if they are not independent, they are forced to agree to whatever others say. So this is one of the criteria I used. So immediately when I was finishing my MSc, I applied for this job because I thought, oh, ISRO is coming up. Let me apply, let me see if I get it, fine, if I don't. And within 6 months, I got the interview call. Those days there were no entrance exams. So I got into ISRO. And I liked the work there. I enjoyed the work, as I said, because it was experimental physics to start with. Yeah. So coming back to your problems, these were all sort of minor problems. Why, is there anybody from Delhi here?
Yeah.
When I finished my schooling, I used to walk to school and come back there. So that wasn't a big thing. When I finished schooling, I got good marks. So my mother said, we were in South Delhi. So my mother said, why don't you join one of these colleges in South Delhi? It will be easier for you to go and come back. And then we went to one lady who had actually done MSc in botany from Delhi. So we went and asked her, how are the colleges, which college you should join, etc. She said, I don't mind you joining South Delhi College, but it's good that you study in Delhi University colleges because it's much better faculty. Then my mother said, it's so far away, 20 kilometers from here. She said, don't worry. There is a university special bus starting at 7:30. Take it, and again evening there is a university special bus back. And so, why I say this is, there's a need for parents to be convinced that there are ways and it is safe. So, so every day 7:30, that was my routine, BSc days. So 7:30 catch the bus, whether you have college at 9 or not, even if you don't have classes, we used to go there. And many of my classmates also used to do that. From various localities, there used to be this university special. And so we used to reach there. And if our class starts at 10, we will wait at the library or the common room or somewhere. And then similarly in the afternoon, again, there were two lab classes only 2 days a week. But other days, we will just go to the library, make notes, wait till 3:30, go for the university special, and come back. Very nice, because I found also that we could meet a lot of students in other colleges and compare notes, and also from other engineering background, etc., because that used to take the route where the other colleges were there. So it was a nice thing according to me. So I really found that the university special was a great thing for me. So that's one thing crossed. If I'm taking too long, please tell me. And the second thing was when I joined ISRO. Those days we used to come back at 5, etc. So there was no, and we used to have buses to office. We were in Pina at that time. So we were living in Vijayanagar, so there used to be buses. And those buses were one of the best things we enjoyed in ISRO, because again we used to travel together, we used to talk to other division people and so on. But then when I started on this thing to Kavalur, so sending me to Kavalur was not an issue, but there, oh, you work at the night and work in dark, etc. But then they were convinced that that's a professional institution. There are many people working there. There were very few people at that time working there. Shailaja, Anupama, that's how I know all of them very, very well. So my first thing there, and in fact, it was a motivation for many of my colleagues to come there because many of them would not like to come and work at night. But then we were. That's it. And that I think helped also when we had to work on satellite projects, long hours and so on. So I think if, again coming, where is the problem? It's the parents' problem to find that it is safe for their children to actually work there and they can come back safely. So I have many times taken even the transport at 9:30, 10, etc. from my office back home. And I used to reach at 11. So that was it.
So next question, as you all know, that Mars orbiter mission is known as famously Mangalyaan. Is India's first interplanetary mission to planet Mars, and after that, ISRO has become the 4th space agency in the world to successfully send a spacecraft to Mars orbit and do it in fast attempt. So, ma'am, you are one of the women scientists to lead that mission. So, could you provide us an overview of the significant challenges that you faced during that mission?
Okay.
And also some significant.
Okay. So when the Mars orbiter mission was proposed, I was already in the headquarters. So I don't have any direct involvement in the development of the instrument or in the, in the project phase as such. But being the program director at the Space Science Program Office, this mission carried 5 instruments. And those instruments were selected by a small committee which was headed by Professor Nuara, and they had a very, very, very big mass crunch. They were given only 15 kg for all the 5 payloads together. So the biggest challenge for all of them was to miniaturize and yet keep the science goals in mind. So 3 payloads came from SAC, 1 from Space Physics Laboratory in the SSC, and 1 from So all of them had this issue of mass crunch. Second was time crunch. this Mars orbiter mission, see, every 18 months or so, you get a chance. See, Earth moves in its orbit around the Sun, Mars moves in its orbit around the Sun independently. And the orbital period of these two are very different. So there is a time which comes every 18 months or so, when if you go from Earth to Mars, you will have the shortest path, and so you can save energy. Okay, so once this project was approved, we had just 18 months for launch. So severe time constraint. Okay, so that was a constraint both for the spacecraft people and for the experiment people. Why I'm saying for the experiment people? Because I was connected with that, and all the instruments were new. The camera was a little similar to what we had done for Chandrayaan, but otherwise the methane sensor, etc., the infrared camera, all of them were new, and even the mass spectrometer was new. So everything being new, they had to develop it, test it, etc. within that short span. That is according to me for the science experiment. So I was in the review committee. I was a member of the review committee headed by Shri Kiran Kumar, and we used to have regular reviews because in order to save time for them, we would actually find out where they are having issues and whom they can contact, whom they can connect with, so that they can come out of those issues quickly. Because if you wait for the regular, always ISRO has been a place where we sort out issues based on reviews. This is a system which has been established in ISRO. So we have a preliminary design review where the preliminary design is reviewed, and then there are many people who give lots of suggestions at preliminary stage that you can do this, you can do this, you can do this, and you have to try out various things. And then in the next review, you have to say why each of those didn't work and why you finally went to one of them. So 18 months, PDR, CDR, everything was so quick. So we used to have these regular reviews, whether they were under so much pressure because they had to do this development and testing, and in between all of us are pressurizing them for it. So I was sort of in between them. Yeah, you come for the reviews. We'll see where the issue is. So after that, after the launch, then the testing phase to get them to test the payloads. Right immediately after the launch, we had this comet, which was going to come very close to the Mars, and so we had to. There was a lot of debate whether the scientists wanted to observe the comet, but then we also wanted to have the safety of the satellite. So it was decided we would be safe from the satellite. So we would observe whatever the remnants are after it has gone past. So so that was the thing, and then so initially itself, whichever payload we could operate while we were going from Earth to Mars itself, like the camera, etc., we operated, and then on the way en route to Mars, periodic testing, and then finally when we reached Mars, the final testing. So I'm glad that we did those challenging experiments because we learned a lot doing those experiments. It was a great learning experience, and to analyze why you see that, for example, the methane sensor, we proposed it because there was a publication saying that there's a very likelihood of several ppms of methane could be detected. But finally, by the time we reached, we knew from the NASA rover that if at all it's going to be few ppbs, and so even from on the surface. So from an orbiter, we knew it's going to be much more difficult, but it was a great learning experience, I should say. So, so that experience has helped us in fine-tune some of our experiments for Chandrayaan 2 orbiter, the infrared camera and so on. So it was great. One thing about the Mars orbiter mission is that it has got the best, I should say, best publicity and best exposure with general public compared to all the other missions of ISRO. Not to to say that the other missions were easy. They were equally difficult, if not sometimes more difficult. But this, because it was the time of social media, and ISRO decided to open the announcements from the social media to connect up with the students and so on. So that was one more reason why this got a great publicity, and of course in the international arena also, because we went there first time, and we were a success. It was a success because if you know, at that time 42% of the missions to Mars were rockets. So we should say that nearly 50% is the success rate, and we went poorly. So and it was for us the first time we were going out to the Earth's orbit into a heliocentric orbit, and then go on and lock on to another planetary planet. So to plan for that several million kilometers and go on there and fire the engines after 10 months and make sure that the firing is right and get locked on into an orbit around Mars was a major challenge. And I'm very, very thankful that I got this opportunity to actually be a member of that big, large team and enjoy that moment of actually being at that at the tracking station when it got into the orbit. And I should say, when it actually got into the orbit, it was a communication. It was behind the Mars. So we did not have data for some 2 to 3 minutes. waiting. Did the engines fire? Did the engines fire for the right amount of time? And did we get the right velocity to get into orbit? And only after it came out of behind the Mars, we knew that actually it was exactly right in the orbit. So exciting time. And one thing I should say was that was a mission where everyone, it's not just the project team, the administrative teams, the students, even those who are not into this project, and even I should say the drivers who were taking us to the tracking station. They were the taxi drivers who were not at all connected with ISRO. Even they were so along with us for them.
I want to ask you that did such kind of movies based on the space mission can make the people to understand how like space missions are important for us, and what kind of effort and dedication are behind a mission in India? Because we always start from the scratch. So what do you think about it?
I would say start from the scratch. For Mars orbital mission, I should say that we learned from earlier failures also, what we should avoid. So, but doing many things indigenously for the first time is a starting point. So that is there. When it comes to movies, yeah. For example, many people ask me, did they consult you? At least I wasn't consulted. Maybe they consulted some other people. But to explain a technical thing in very technical terms, sometimes you lose the public. So it helps to sort of, so they have made a few dilutions, I should say, in the movie. But I think as long as it conveys the difficulty of what members go through, and that's what I think the mission, the aim was in that mission, that what difficulties the team faced, the members faced, and also when including the weather, for example, the launch postponement, etc., etc. Yeah, so that was brought out very well according to me, so that helps according to me, because if they maybe they did consult, and maybe they should consult and make it a little more scientific, a little more technical, and the agency also should probably be willing to then interact with the movie companies, because that's also essential, right? If initially they may also not be, they also don't know how they're going to make it, right? So that's also essential. But I think it does convey both the difficulties and the excitement. And so general public, I think, enjoyed that. But many people ask me, did you really learn anything from making puris? I said,
as we discuss about the public awareness and understanding that these projects are how important it is and all. So it is equally important and equally significant, like how the public is getting aware about the ongoing projects and all. So you have been involved in these outreach programs and all. So like what was your motivation or like your inspiration to join for such outreach activities?
Good question. Because when I joined ISRO, as I told you, I was heavily involved in with developing the instruments, doing the science, etc. from astronomy. But so it was a very, very what do you say, shielded life, I should say. I used to give lectures, etc. I have given courses, I have given lectures to science community, but not really public lectures, so to say. But then when I went to headquarters, and especially when I found that we were embarking on these science missions, like Chandrayaan 1 was the first one, which was a full-fledged mission. See, till then, what we used to do is, we used to fly what we call piggyback experiments. We started with gamma ray burst experiment on the SROS satellites. So that was an experiment along with the atmospheric science experiment. Then we flew the Indian X-ray astronomy experiment. Even then, we didn't get a dedicated satellite for it. We flew it on a remote sensing, IRS P3, Indian remote sensing satellite P3, which was flown on PSAT. So it had both a remote sensing experiment and our X-ray astronomy experiment, which we jointly developed along with TIFR Mumbai. So we time shared. At that time, the remote sensing experiment, luckily for us, was an optical experiment. So during the monsoon months, even if they see the Earth, they can't see anything because of the clouds. So we used to see the sky. Yeah, starting from June, July, August would be our months to observe using. And luckily for us, it's also the months when we see the galactic plane and many of the sources like Cygnus X1, etc., etc. All the sources from say 16 hours array to around 22 hours array. Yeah, so great thing. Of course, for Crab, to see Crab Nebula, which is 5 hours array, we had to take special time. But otherwise, all these bright X-ray binaries were in the galactic plane, and so ideal time to observe. But still, 3 months. We would request them, please give us some more time, please give us some more time. Not me, actually, Professor P.C. Agarwal was the PI of the experiment, and he used to go repeatedly to the project director, program director, and ask, please give us some extra time, and that's how we made. But the big thing about the astronomy experiment is it's quite demanding. The IRS-P3 experiment was the first experiment which actually pointed to individual sources in the sky. That demand came from us. Because gamma ray burst experiment was like a survey. We had 180-degree field of view wherever we looked. That's fine. We used to localize with other experiments on other satellites. But this one, the demand, and star sensor was new at that time, developed by the Laboratory of Electro-Optic System, LEOS. So we put to use the star sensor to find out where we were looking. So were we looking correctly? Otherwise fine-tune where we were looking, and then see whether we are actually looking at the x-rays. So that was again a great learning experience. In fact, now remote sensing experiments, often they calibrate using stars initially. So that was the first time we did stellar pointing with an Indian satellite. And that gave us the confidence to actually propose for AstroSat. So again, Professor Agarwal and Professor Kameshwar Rao from here, there were 2 committees formed. Professor Agarwal actually put up a proposal that now we should have a dedicated astronomy satellite. And then ISRO formed 2 committees to look into X-ray, gamma ray, etc. and optical, UV, etc. and see whether we can get a synergy between the 2 and decide on what experiments to do. And that's how the final proposal was put up to ISRO. So that's the background. So till then, till I was in URSC, I was not into too much about it. When I went to headquarters, I felt we are doing this Chandrayaan 1 mission, and Mars Orbiter mission was on the anvil. AstroSat mission had already been proposed, accepted. We were building this instrument. and not many people know about it. Even now, it's the scientific community which knows more about AstroSat, whereas the planetary missions are known by the public. But at least the scientific community knows. I mean, students who are pursuing science, etc., know about AstroSat. So that's when I realized two things that we have to actually make an effort to. ISRO was, at that time, they would give the data to scientists and scientists had to do everything. So I felt even from ISRO we should mobilize the thing. So that's how the AstroSat picture of the month came about with ASI, with Neeraj, etc. Then we started something called the Story of the Week, which is continuing. Story of the Month, where we would put the story along with the public relations. They were also keen on having a story which would be put on the website. So that was one thing. And the third thing was actually making the data available for researchers at least who would be in the universities, could at least get some hands-on on the data. Otherwise, they were using data which is freely available from other satellites. We have to ensure that they make an effort to use the data from our own satellites. So that was another thing which we made. We also made atlas of Chandrayaan-1 images and Mars orbiter mission. The Mars orbiter mission atlas is downloadable actually. So that in fact, I tried my hand to get some science and arts together to see if we can do some project like that, so that we can get a more public interaction. But that hasn't gone forward very much. So waiting for that.
Yeah, we recently heard about the project Cosmos.
Yeah.
Yeah, so like actually what is the vision of that and objectives also?
Yeah, so Cosmos, I'm a member of the Cosmos project. Outreach team, not the Cosmos project per se, but the Cosmos outreach team, because it's a plan to actually start the public knowing about astronomy, about the universe in general, the excitement of knowing about how the universe functions, and the excitement about how it is done. That is the point. I mean, how do scientists work? So the starting is with the setting up of a planetarium there. But the planetarium itself is going to be used also to exchange with the public and the students knowledge about how we do science, how we do astronomy, how they can get involved in the various things, and so on. So that's how I got involved in this outreach project, and even otherwise I'm more involved into outreach activities now rather than core science activities, which I've left to my younger colleagues.
Moving on to the next question. Is ground-based observations has limitation for certain wavelengths? So in this multi-band era, space astronomy plays a crucial role in expanding our knowledge of the universe. Last year, India's first dedicated space astronomy observatory, the AstroSat, completed 7 years successfully. So could you give us a brief overview of AstroSat and your specific involvement in it?
So I have been a member of one of the committees. No, in fact, because we also proposed an optical monitor. Being an X-ray person, we thought we should monitor the optical counterparts of the X-ray panels. So I was in the one of the committee members, and then we started in URSC. We started developing one of the instruments called the scanning sky monitor, and I was a PI for that. And so each of these experiments, again, some of them totally indigenous development. Some of them joint development, like the UV imaging telescope is a joint development with foreign collaboration, including the Canadian Space Agency, and also the soft X-ray telescope is a collaboration with University of Leicester for the detector systems. But the large area X-ray proportional counter, the zinc telluride imager, and the scanning sky monitor were all indigenous experiments. So development of it. So the proposal was approved and we got working on it and so on. The project approval itself happened around 2004 or so. And then we started developing. And And then, as I said, review processes, etc., as usual. Then, there were several indigenous developments to take place. X-ray optics, first time at AFO. UV optics, first time US. Detector systems, even though we had collaboration, to actually define them, to actually make sure that they work exactly as we want, first time. And at that time was when we were entering, even the engineers were entering into this FPGA based systems for space-based. So that was another new thing for them. Because till then we used to use standard electronics components. Now they with the FPGA, everybody decided that we should use FPGAs to simplify the electronics. But it was new for us. So that was new. Then, that was one part. The second part was to actually get the satellite teams, both the hardware teams and the mission teams, to understand what this project is. They knew, the ISTAC people knew that it's a stellar project, and that 4 instruments were to be co-aligned and they would look at the same object. But it was not just stellar pointing. It was that we wanted to avoid the sun, we wanted to keep away from the sun, at the same time maximize the time. We want observing the star, we wanted less charged particle background, therefore low inclination orbit, which PSA we have not done till the end, low Earth, and then though they have done GT, they have not done low Earth equatorial orbit, and then getting them to actually operate each of these payloads in a proposal-based way. That was a major thing for us, because we decided somewhere in the middle that if only the PI teams propose for it, then the data will be limited, the data usage will be limited, there won't be many scientists coming into it. So at some stage it was decided it should be a proposal-based thing. We should operate it as a proposal-based observatory. Now that being the case, this was new. So to create tools for that, including those who have proposed for it, APPS, was a marathon task. And to get the mission team to actually interface with that tool, once the proposals are proposed, get that to convert it into actual commands. And ensure that none of those commands will be wrong. Because you can't do it every time manually, right? It has to go in an automated loop. Only in the first few months you can do manually. Otherwise, it's not possible to do manually. So all this also took a lot of time. So time-wise, we were blamed very much. We are taking a long time. But luckily for us, the 2 project directors were there, Dr. V. Koteshwar Rao and later Mr. K. Sharma. They understood that it's a science satellite. It should perform as per the science requirements. So if it is essential that this has to be done, it has to be done. So that's how we finally went as a proposal-based observatory, and the data is getting disseminated, though there are hiccups even now, but largely goes in an automated mode. And thanks to all the team members. Without them, this wouldn't have been possible at all. Both the science teams and the ISRO teams. And there used to be big fights between the 2 teams, and I used to be in between. So from 2011, when I took over as a PI after Professor Agarwal retired, that was a major time because I had to leave the SSM and then go on to bigger roles, and so the calibration, making sure that the ground calibration is done properly, and so on, to the extent which is possible. See, on ground we are not able, we don't have some calibration facilities for X-rays at all. A parallel beam for a soft X-ray telescope was not there. It's not there in India. If at all we had to do, we should take it to NASA and then get it. So we couldn't do. So we could do the calibration with the integrated thing only in optical So that being the case, all that. So we did all these reviews as a team. As a team. Each of the PIs, 5 PIs, and their teams would question the other teams. And we would go to the place where it's developed to even know the nuances, the difficulties, then do this, and finally we are through. Even, I should say, even on the launch day, the scientists were like, let the launch happen, let the launch happen. But they were so happy, I should say, because immediately after the launch, we came to know that it was right in the 6-degree inclination orbit and at the right altitude also. So they were so happy, and came back, we started working ground-based. It still, even though we did all this, it still took us more than a year to finalize the pipelines and all that. And in ISRO, the teams move. You see, they stay with the same project for 3 months to 6 months. After that, the same team starts working on another project. So that was a challenge for us, to bring them back, to ask them queries. Even now I ask them queries. I can call them up and say, hey, I'm Seetha. Please let us know how to do this. We want this new thing. But it's a great experience, I should say. And and being the first dedicated satellite, I think both sides are happy, though nobody will be 100% happy. There's always room for improvement. And I hope that I'm looking forward to Aditya L1 being one step more than, better than AstroSat. And there they would look at one object, not multiple objects. so that's one more thing. If you had done Aditya first and then got to AstroSat, it would be probably easier, right? We went to multiple objects, multiple pointings, everything, and now you have to come to one object. So that's
You have more to share regarding that, some memories from the collaboration with IA.
Very good memories. That's why I said my initiation into astronomy itself was through the rocket experiment and this optical astronomy. So fascinated to see the skies in Kabalur, and so we used to apply for about 10 days every year. Those days, I should give you this experience. There was one more team in IIA. Many of them are not here; they are retired. One, Dr. Mohin and Ravindran. They were doing photometry, and we were doing photometry. We two were the people who were doing photometry of stars. Okay, asteroids, etc., etc. There was another team by Professor Raj. So they used to do it with the strip chart record, and then they would digitize it. We were doing it digital. What was the digital part? We had a photomultiplier based photometer. Initially it started with single channel. That signal would come to nimbins. I don't know whether you have heard of nimbins. There are these big power supplies, and into which bins will go. I don't know, if you go to the gamma ray experiments, you will still see nimbins. The preamplifier, etc., is still in the form of bins. So these are pluggable bins. Okay, so we had the amplifier, counter, etc., as bins. So there would be this bin which is about 1 foot, and the nimbins, and so it would feed to the preamplifier close to the telescope. Then the signal would come to the post amplifier, then the counter would go to a printer. We didn't have PCs at that time when we started, 1982. So it would be a Hewlett-Packard parallel printer. Why parallel printer? Because we wanted to go to 1 second integration time, etc. So serial means we will lose some intermediate samples. So parallel printer. So sometimes we used to take 1 second, sometimes once every 10 seconds. But the time, and we have even run it at 200 milliseconds. So this printer used to print, tuck, 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 tuck. Every time it makes a print. Time and counts, time and counts. Okay, so it would be on a roll of paper like you see in the malls now for bills, and we would take this back get some people to actually convert it into cards, and the cards would be read by the main computer. That's how it used to be. Okay, so once it is run into cards, we would print it out, verify that all the printing is correct, and then give it for analysis and do the time series analysis. So primarily we were involved in time series analysis, searching for periods, aperiodic phenomena, flares, etc. So only 2 teams working on photometry, and everybody would know ISRO team has come because of this tak sound every second in Kabul. And to go to Kabul, no vehicle, no cars. We would put all these instruments. So this was a 3 kg or 4 kg printer, and the Nimbins again was another 5 kg or something, and carefully take the photometer. That is a delicate thing. So we would do all this and pack it into a vehicle, go to the railway station, get it weighed, because suddenly somebody shouldn't come to for inspection and say, hey, you didn't weigh it and you are charged for excess baggage. So weigh it, get it loaded into the train, and go to Jolarpet. From there, IIA would give us a jeep with which we used to go. So this marathon travel, and so that was a motivation for us to go for a lightweight photo, for the development of a lightweight photo. So difficult things motivate you to actually do better things. So initially we had a single channel. We got some of these things which went into flares, some stars. Vainu Papa was there. Very, very lucky to have interacted with him at least for a few times. When we present the results, he would say, he and the others would say, how are you sure it is not caused by a vehicle going near Kavlur? How are you sure it is not caused by somebody flashing a torchlight into somewhere into the opening of that? So that was another motivation that we should go in for a 2-channel photometer. We should observe either a sky or actually ideally another star near the star, so that if both of them give the same variability, we throw out that time. Otherwise, we use that time. That's the principle. Then, luckily for us, so all these things about location, RA, deck, etc. I learned from optical astronomy, I should say. Yeah, because so I had this merging of both X-ray and optical astronomy. And there used to be people, and there are clouds, Rosario, etc., who were the people who worked with us. And then they used to sit, if there are clouds, we used to sit outside on the catwalk and observe the sky. And they used to point out the bright stars and so on, because I really didn't know. And so that's how I learned about the sky itself. So great experience at IIA. We also initiated the 5:30 breakfast at I don't know if many of you use it now, but we were teams. Many of the IIA teams used to say, okay, we have finished observation, we're going to sleep now and then get up for breakfast. We would say, no, once and for all, we just have breakfast and go to sleep. We don't even mind missing lunch. We go straight for dinner. We used to have dinner before observations. 6:30, have the dinner, go. Once you go to the observing floor, we are not coming back till early morning. So that's how it was. So we introduced the 5:30 breakfast. And then so gradually we requested IIA that on the 40-inch first floor, can we put a cupboard where we can put all these nimbins so that we don't have to carry it every time. We could just, and they really helped us to keep those things. 1985. Major thing was we had the IAU General Assembly in Delhi. Major event. Why I say this is, ISRO did not have too many foreign collaborations. IIA team members, etc., used to go for conferences, etc. We had in 1982 or 83 the Cosmic Ray Conference in Bangalore, which we attended, where I presented my first paper on some of the optical observations. Yeah, international team, and here I am, just having 2 or 3 years experience in ISRO and presenting this thing. And then 1985 there was this big IAA General Assembly. We got to meet team members who were connected with the whole Earth telescope. We had expressed that we wanted to make a 2-channel photometer. We had made a design. We had got it on the workshop, etc. But then some of the members who had built instruments for whole Earth telescope came for that conference. We got talking with them, and they gave us some suggestions. And that's the motivation, more motivation for us to build and finish that 2-channel photometer. And we got it working in 1987. 87, the first run, and this person called Ed Nether comes all the way from USA saying, we would include you as a member of Whole Earth Telescope only after I see how you operate it and how it functions. Whether the family is correct or not. That was his thing. So here we are going for the testing, and here he is. So testing in front of what I call quality assurance. So that was very good because he immediately approved it. Chris Clements and Ed Nether had come. And that was the time we got PC. Justification, we were one of the divisions when we got the first PC XT in our lab. Even some of the ISRO groups did not have PC. We said we wanted, we had to demonstrate it to him, and luckily for us, Dr. Kasturi Rangan, you are now all there in senior position. We got this PC XT, they gave us an interface card which we mounted inside the PC, and so the nimbins and all went out. Now we were going to carry only the PC with the interface card. PC also is a desktop with a terminal which is very big, not very easy. But now the data comes in digital form. No more printing, no more checking, no more. That was a great boom. So that's how we got into this collaboration with Whole Earth Telescope. That's how I got into white dwarf pulsators. And finally my PhD, I was supposed to do my PhD on gamma ray bursts. But because SOS 1 and SOS 2 didn't reach the orbit because of launch vehicle issues, and I had already registered 4 years completed, what should I do? So then I used the Whole Earth Telescope data, into which we also had some data, and I did my PhD on white dwarf pulsators. So you can see optical astronomy plays a very, so that's how I connect very well with IAA people, you see, whereas many of my younger colleagues don't connect so well. So I'm always happy to come back to IAA, and we also had this neighborhood astronomy program started at that time. Very nice program because again ISRO, we never got chance to move places, but we used to go and attend these meetings, and we came to know what other students are doing, how they are doing, because as I said, no email. How do you communicate? It's only when you see them, when you meet them. So neighborhood astronomy meetings played a very important role. IAA, we used to come for talks. We used to come because it was, even from Pina, we used to travel within half an hour. That's another miracle. So this was the room where we used to have those talks. This was the same room, and we used to come for the talks where it's connected. So the connections with IAA go back to the 80s.
Like adding to that, out of curiosity, like did you find any significant difference in the research culture like in IAA back that time and now? Like, are we missing something?
Yeah, definitely. When we used to come to IAA, we know many people. We know that they are working in solar. I don't work in solar, but we know those people because any talk, everybody would attend, we would get to meet them, and oh, you're working in this. Sort of just talking. Talking was the main way of interfacing that time, right? No chat. No. So, we knew several people. That's how we know several of even the senior people. We meet them either at Kavalur or here. Kavalur, we used to meet Kembavi. He used to come for observations. We used to meet KP Singh. He used to come for observations. Yeah? So meeting ground was there. And as I said, the community was not very large. And we used to know each and every person. Now, of course, the community has grown. But I think students especially, you might feel that, see, for us, if you have to do literature survey, we have to go to library and hunt those abstract books, find out what papers are published. For you, it is very easy now with internet. But that easiness has made you limited to papers only in your field. Whereas when we used to do literature survey by going through Astrophysical Journal, oh yeah, hey, this paper seems interesting. At least read the abstract. That's all, not much. We want to understand half the thing. See, that's the point. Now you probably understand all the papers you read because you're reading it in your. But we would not understand half the things. But awareness used to be there. So that's the thing I think you people are missing out. And if you can bridge that, then you can interact with more people. Or even after your PhD, you can branch out. Because at postdoc level, if you do a different thing, then when you go for a career, you have a better advantage than limiting yourself into the same field. That's the thing I think.
Okay, so next question, what are the upcoming significant space missions planned by India? And in your opinion, what is the future trajectory of Indian space program?
Okay, so the immediate science missions are, one is the XPOSAT, the X-ray polarization satellite, which is a payload. It consists of two payloads, one developed at Raman Research Institute. It's an X-ray payload. It will study the X-ray polarized X-rays from X-ray sources. There is another payload developed by the Space Astronomy Group of UR Satellite Center, and they will study the spectra of the same X-ray sources. So it's going to be spectropolarimetry of the sources. So that is due for launch. And of course, as you know, ASINDIA L1 is getting ready for launch. So when the launch will be, ISRO will decide based on the final tests and what I would call clearances, and then it would again take, after the launch, it would take about more than 3 months to reach the L1 orbit. But en route also we will have some operations also, and then we look forward to having a good observation of solar max and beyond this cycle, and hope all the payloads. There are no expendables like gas filled detectors, so we hope it will also would operate out to the next cycle also. We are also always optimists. And that's the science mission so far, approved science missions. Of course, there are proposals for a mission to Venus, a mission to study the ionosphere itself of the Earth, and probably an exoplanet mission, and various other proposals are on the line. One for observing transients, including gamma ray bursts, and maybe neutron star mergers, which will emit in the electromagnetic spectrum, so that we could detect the gravitational, we could simultaneously detect the electromagnetic signature of the gravitational wave sources. That's called the Daksha. That's also under proposal. These are all not approved. Then we at RRI, there's also a proposed experiment called Pratyush to study the early universe, and that's the first radio frequency payload proposed for a satellite, along with University of Pune, which has also proposed a radio frequency payload. So many of these are in the pipeline. The other major mission, I should say, the remote sensing and the communication things will be there. We're looking forward to having on our mobiles the Indian navigation satellites providing us the equal, I won't say equal, but our paths within our country. NISAR is a major project. It's a collaboration between ISRO and NASA for remote sensing, and the payload itself has arrived and it will be get launched soon. So you will see some major results coming from there. So the journey continues.
So moving on to the last question of today's interview. So what advice would you give to aspiring young individuals interested in pursuing a career in space science?
Many of you do get space science data because it is made available, and there are many people who have worked behind making the data available in science ready form itself. So we ourselves have used data from NASA satellites, and we're grateful to those team members who have really not only contributed to the experiments but also providing us the data as and when needed. So those who want to get into space science, don't limit yourselves to only data analysis. Contribute in some way to space science missions. I know that many of you might feel that we don't know how to get into it, right? I mean, I know this issue is there, but maybe you should know the people who are working in those missions and ask them in what way we can contribute. It helps to be proactive. There are many ways in which people can contribute, and so it's not just only in the hardware. You don't have to spend all the 10 years developing the instrument. You don't have to develop all the software, but there can be small areas which needs development. And I think it's also the I would say responsibility, but I would say it would be great if the teams themselves came forward to say, we need this. Would any of you be doing this? That would be nice, so that the younger members can actually contribute. And younger members not only from the astronomy community, but also say from computer science, from mechanical, whatever, to do this. Always the space science teams is too hard pressed for time, and so they're always into these things. After they finish the onboard systems, they have to work on the ground systems for making sure that the pipeline is correct and so on. So many times they may not realize the help they would get from involving some people. They see it more like they have to educate them before they. I know they have to educate, but if they do that education, spend some time with the advantages may be numerous. So because they don't have that time, those who want to get into space science, please be proactive. Go and ask. If not the team here, go and ask the team somewhere else who are working on space projects and say, this is my expertise. I would like to work on this. If you have anything, please get it. Almost like a summer internship. Just be free. So that why I say that is, it might also give you an idea of where or how you can contribute. It gives you a thinking process, you see. You yourself might be able to think where I can do. We always get limited by maybe, okay, the instrument is built, what else can I do? That's not good. Till now I'm working on this. And for example, there is just last week we were discussing, downloading each orbit data is a pain in the neck. Please make sure we can download the simple data of a particular observatory. First requirement. Second requirement, please ensure one object, all the data sets, we can do bulk download. This is a requirement. Now, people help in creating pathways for this with the ISTAC team. I don't know. ISTAC team has to say, no, this is what I want. They are always depending on the university. Now they are hard pressed for time. So it keeps going on and on. So maybe we should have somewhere your capabilities, and I should ask the ISTAC team, hey, are you willing to make use of some people wanting to work on this? Would you like to involve them? It's after all a back-end software, right? They can always put it through a testing phase and do it, right? So, even improvements in APPS, you can give suggestions, and then they can say, hey, yeah, the suggestion is very good. Would you be involved in that itself? Yeah, getting into space science, I know, is difficult. Openings are less. We want to expand our communities, but till project is approved, they cannot open up the things for careers, formal careers.
Okay, so that was the last question from us. So before concluding this interview, we would like to express our gratitude to Dr. Seetha.
Thank you. It was my pleasure. It was nice talking to you all, and it's a pleasure for me to interact with all of you. And I hope you have great careers in astronomy, outside astronomy. It doesn't matter. Your learning processes will stand you in good stead